Inductors. What is an inductor? It is defined as a passive component that is used in electrical circuits to store magnetic energy when current flows through it. One thing to keep in mind is that an inductor resists change in current, and we will see that later on. Now let's look at how they work. In phase 1, the battery is on, so current is increasing. But the resistance of the inductor L is too large for current to flow. Here, current increases, so L tries to stop it by creating an opposing force called EMF. Therefore, current takes the easier path and flows through the lamp to power it on. As for phase 2, current keeps flowing. The resistance of L decreases to allow current to flow. So some current flows across the inductor, generating a gradually increasing magnetic field, and more current will flow. Eventually, the resistance of L will be zero and also EMF becomes zero. The current will stabilize and the inductor acts as a wire. Thus, the current prefers to flow through the path of L instead of the lamp, which will turn off, and the magnetic field is maximum with energy being stored. As for the final phase, phase 3, the battery is off, so no current flows in this circuit. But the stored magnetic energy will be converted to electrical energy. The magnetic field is being depleted. Here, the inductor acts as a generator, which continues to push electrons through the lamp, which turns on, so there is flow of current. The current is decreasing in this circuit, so L tries to stabilize it or to stop it by pushing the electrons. This continues for a short duration until the resistance in the wires and the lamp dissipate the energy, and the magnetic field is completely depleted, therefore the current is zero. One application of inductors in the real world is transient surge protectors. A transient surge protector attempts to limit the voltage supplied to an electric device by either blocking or shortening the current to reduce the voltage below a safe threshold. Blocking is done by using inductors, which inhibit a sudden change in current. These surges can come from lightning strikes, power line crosses, or other disturbances in the electrical grid. What is the role of the inductor in surge protection? First, it stores energy. Inductors store energy in their magnetic field when current flows through them. In the event of a surge, the inductor resists rapid changes in current, helping to limit the rate at which the surge current reaches sensitive components, effectively preventing damage to downstream electronics. So this is another role of the inductor, which is current limiting. Another role is filtering. Inductors act as low-pass filters in surge protection circuits, allowing normal operating currents to pass while blocking high-frequency noise and transients. So surge protection circuits often use inductors in combination with other components like capacitors, resistors, and diodes. The inductor's inductance value determines how much it resists changes in current. Now, let us go through this example of finding the current across the inductor. We first know that the formula I of t is equal to 1 on L, integration from 0 up till tv d tau plus I t0. This is already 0 from the given. Now we can substitute for L, which is 5, and for V, which is 30, tau squared d tau. If we take the 30 outside, we'll have 30 on 5, and if we solve this integral, we'll get tau cubed on 3 from 0 up till t. If we take the 3 outside, it's a constant, and if we substitute for t, we'll get t cubed minus 0 for 0. So the answer will be 2t cubed amps, the unit of current. The second thing they asked us to find is the energy W at the instant t is equal to 5 seconds. We already know that the formula for W is half Li squared. However, the current should be at the instant 5 seconds. So let's find that first. I at 5 seconds is simply 2 into 5 cubed, which is 125 amps. Now, let's go back to our formula. So W is equal to half, L is 5, the current I just calculated is 125 squared. Plugging that into the calculator will give us 156,250 joules.